before. So from 2018 to 2019, there was a roughly halving of the number of crab out there. 2020, we unfortunately didn't have a survey, and then 2021, there was just nothing. Relevant to this story is that the cold pool was the smallest on record, and that's this blue line over here. And this dot here and this dot here, 2018 and 2019. Snow crab like cold water, they're associated with a cold pool, so this is a problem. These figures over here just show their rough distributions. They're widely distributed in the Bering Sea. Each of these squares is a survey tow. So in light of this collapse, the stock was declared overfished. The fisheries closed for the first time ever in 2022, and we've got a rebuilding plan underway. I want to give you just a little bit more information on the fishery and the population, so you kind of have some context for what's happening. Like I said, they're widely distributed. Each of these are survey tow. We've got survey going back to 75, but above this red line in the northern Bering Sea hasn't been consistently surveyed, was only started to be consistently surveyed from 2017 forward. And in spite of this wide distribution, the fishery occurs down here because that's where all the large males are, and that's what people like to eat. And they get down there after an ontogenetic migration. So we've got mature spawners down here. They release larvae into the water. They're infected up here, and then they walk downward over time. And as they're walking down that shelf, they undergo a terminal molt. So they'll molt to maturity, and after that, they don't grow anymore. And the males and females molt to maturity at different sizes. This is a male and this is a female. And this dimorphism really facilitates the male-only fishery that we've got. Otherwise, it would be difficult to keep the females out. I should also say that this is a very romantic mating embrace here. The males get big, so once the females molt and they're very vulnerable, they can grab onto them, hold them until their shells have hardened, and then they mate and go their separate ways. So over the last year and a half or so, there have been really three questions at the top of mind for everybody thinking about crab. And it's like, what happened? What do we do now? And what does this mean for future management? And this really let me go back to my very first year at SAFS, where I got to read The Ecological Detective, and it's still one of my favorite books. I think I worked through it using Excel, actually, which was good times. But this is really turned into a detective problem, trying to figure out why something happened and discerning among a large number of different potential hypotheses. So the things that I would like to hear back from you guys, and you guys online as well, are thoughts on these overarching themes. And the first of which is trying to understand time variation in confounded population processes like growth and mortality and catchability and stock assessment. I'd like to hear your opinions and thoughts and experience on how you've modeled those things or done experiments to provide data to try to unconfound processes. I think identifying environmental drivers has been I guess there have been a lot of papers out there, but there have been a lot of pitfalls associated with it, probably associated with the short time series and nonlinearities and some of the interactions between variables that we look at. And so I'd be interested to hear your experiences and thoughts on that. Reference points in changing environments are proving to be very difficult. I'm going to talk more about why this is in just a bit. And we'll probably get less into EBFM in the future management directions, but it seems like something is going to have to take the place of maximum sustainable yield-based management. I guess it's up to you guys to figure it out. All right, so what happened? First question. We had two big buckets of possibilities. Crab are alive and they're out there, we just didn't see them, or the crab are dead and we're not ever going to see them again. And the first order of business was to try and collect some evidence to talk to each of these possibilities. So it could be that they moved into the northern Bering Sea, and luckily we've been doing surveys in the northern Bering Sea consistently. And there were still crab in the northern Bering Sea in 2021 after the collapse in 2018 and 2019. But the densities that we saw and the size ranges were the wrong sizes and the wrong densities to have been able to account for those that were missing in the Eastern Bering Sea. So we don't think that it was the movement into the Northern Bering Sea that could account for this. Could be that they're still in the Eastern Bering Sea, but the survey didn't see them. Luckily, we've got another crab that looks a whole lot like a snow crab, the Tanner crab. They're roughly the same size. They're morphometrically very similar. But we didn't see the big fall off in numbers in Tanner crab from the survey that you would have expected if the survey didn't perform as it should have. It could be that the crab moved off of the shelf. So basically, we're saying, oh, the crab were here. They could have gone this way, this way, this way, or down. There is shelf habitat where we've got slope, or there's slope habitat where we have surveys, but they don't select for crab very well, and they are infrequently done. But the upshot of, I think, all of this is that the habitat on the slope is very, very small compared to the habitat on the shelf. The missing crab were small and way over here, so the walk to the slope would be a tough one, and not something that we think they would do. And most of the slope habitat is further south, which wouldn't be the direction we would expect them to go. Yeah.
Sorry to interrupt.
No, please.
Is the theory behind this particular idea that they would have moved into deeper water to find colder waters?
Yeah, I think that that's reasonable. Everything was pretty warm on the shelf there in general, and there's actually the trend on the Bering Shelf is actually the deeper you go, the warmer it usually gets. Okay. And that's because of the cold pool. I don't know about the slope actually, okay. But on the shelf anyway, that's what you're looking at, and that's because of the cold pool and the ice. The cold pool generally makes a big tongue of cold water right here that excludes the deep and but I think that's also I guess I don't know how they would know that it was colder on the slope. Okay.
I mean, the list of theories is just they went somewhere, you looked everywhere.
Right, okay. Right. And I guess I should say that we didn't actually look here, but the idea is that the potential habitat available is so small compared to the number of crabs that would have had to go into it, and they would have had to walk a very long ways for where they were and the size they were.
Are they caught in bycatch? Have they been seen in other fisheries?
Yep, I will talk about that in a little bit. Bycatch is, so the most frequently asked questions to me are, did cod eat them all, or did the trawlers kill them all? And I'll talk a little bit about why I think that is or is not the answer in just a little bit. So it could be that the crab moved into Russian waters as well. We've had some densities of at least the industry preferred males concentrated up on this border between our water and their water. So is it possible that they moved into Russian waters? And unfortunately, the relationships between Russia and the US are a little frosty at the moment, which is a bummer, because I really wish that scientists could talk to one another. But I was able to find this publication online that talked about the fishery in the Western Bering Sea, and these dots are the centroids of where the fishery occurred, and these are just right up along the border between our waters and their waters. And if you were to, they also have the CPUEs, which is the black line here, and if you were to move a bunch of our crab into their waters, particularly in the numbers that are missing, you might not expect their CPUEs to decline in 2020. So that's kind of a piece of information that leads me to think that the crab didn't just walk into Russian waters.
So does that maybe indicate that on the other side of the border, they were experiencing a similar decline that was happening on
Maybe it doesn't look like it was nearly,
dramatic.
yeah, like I don't know if I have a figure of our CPUEs, but they go off a cliff.
Yeah.
Like they were the lowest that we've seen in the 2021 fishery ever.
Okay,
Our CPE or survey?
The fishery CPUE.
there was,
Also down.
Yeah.
More steeply.
Yeah.
so this is landings. We didn't have a 2020 survey, right?
These are Russians. We didn't have a 2020 survey. The 2020 CPUE was down. The 2021 CPUE was down further. I might have to figure that later on.
And because that was just scraped from a publicly available, this is all that we have.
This is all I've got.
Okay.
Yeah. Unfortunately. And I mean, the same argument for why they wouldn't, one of the same arguments for why they wouldn't go to the slope can be made for why they probably didn't walk into Russian waters. And that's
far.
It's far, and these were small crab. Like the bulk of the crab were down here. They would have had to walk a fairly long ways to get there. And these guys are in the 50 millimeters carapace range, and that's kind of the hunker down and hang out size, not the walk around and try to find a mate size. Okay. Okay, so then that kind of covers the potentials for, or that we thought of anyways, for the crab were alive. Now we can move into the potential reasons that the crab are dead. We're not going to see them again, with predation being one of the big ones. We've got stomach data from cod captured in the survey, and each of these dots are crab found in cod stomachs in the survey. This is just a picture of some of the chomped up crab coming out of the stomachs. These are the sizes of, so these are crab consumed over here on the left by year, by size. You can see again that most of the crab consumed is under 35 millimeters carapace width. In recent years, there's been a bit of an increase in larger ones, but still basically everything is beneath 55 millimeters carapace width. So Kira Maiden and company at the Diet Data Lab put together a time series of snow crab consumption by cod in the Eastern Bering Sea. And it really did tick up in 2014, 2015, and 2016. But that also corresponds with the influx of that big pseudo cohort that we saw. Could be that the crab died due to disease. Bitter crab disease is a dinoflagellate, I guess infestation is the wrong word, but a dinoflagellate parasite that gets into the crab and is thought to be fatal. It had a large tick upwards in the last several years. These are visual prevalence data. We know that based on some work that Aaron and a bunch of other folks have done in Kodiak and elsewhere, that the visual prevalence data can undercount the amount of disease in the population. So these kind of have to be taken with a certain grain of salt. There could be temperature effects that impacted the population. We know that the cold pool, which is represented by the darker blue color here, has changed dramatically over time. We had a huge, big cold Bering Sea in 2012, and in 2018, we had just essentially no cold pool at all. Based on some laboratory studies, we know that the temperature impacts the caloric requirements of crab, but they seem to do well with respect to oxygen up to 18 degrees Celsius, which is something that we don't see at all in the Eastern Bering Sea. Could have been fishery effects, but the missing crab, again, were largely of the sizes that were not vulnerable due to the directed fishery. This red line is the size cut off for the preferred size of commercial crab. So they're fishing on this portion of the population, but it was really these guys that went missing. Bycatch picks up some of the smaller size crab sometimes, but in general, it's been trending down over time. The final hypothesis we ran through was cannibalism. Question? No? Will it pop up on me too here?
It
Maybe?
might. I think the chat, you can usually see the question box for whatever reason. Yeah, I can see. It's
Got it.
organized.
Okay, cool. So cannibalism is another potential. We know that big small crab eat small, big snow crab eats small snow crab. And beneath about 50 millimeters carapace width, based on laboratory studies where they basically played gladiator with different sized crab and saw who won, suggests that the big crab, 95 millimeters carapace width and above, will generally kill a crab 50 to 55 millimeters carapace width and below. But if you're above that, you might get away with just a lost leg or something like that. So I put together an index for cannibalism. Each of these maps show the overlap of those large males with the smaller males. The blue is the overlap. The red is where there were just the larger males. The green is where there were just the smaller males. And then using the amount of overlap, the density of crab in the overlap, and the proportion of the small crab in the overlap, I made an index that roughly, I guess, mirrors the potential for cannibalism in the stock. Yeah.
Can you go back to the frequency?
The which one? Yeah.
What I see there is that sometimes there is a big cohort, and that cohort supports the fishery for a couple of years, and then suddenly another big cohort happens and supports the fishery as well. My
Absolutely.
question is like, what are the environmental conditions? I mean, why those big cohorts?
Yep. Give me about 70 slides. I'll tell you. Hopefully fewer than 70 slides.
And I have another question. This question is related to that one. Like, you mentioned that it's the first time that this fishery is low, but I see that there are a couple of years you can see that very low abundance. For example, 2009 or 1999.
Yep. Yeah, totally. So in 1999, the stock was declared overfished. It slowly rebuilt over that time, and while there was low abundances here, this is like the boom years of the fishery. There were catches that were 3 to 5 times higher than anything that we've seen in the last 20, 30 years, and we haven't seen those again since. But even though it looks like there's barely anything out here, there's enough to sustain a fishery that, I'm not going to go all the way back, but that is fairly valuable.
Was 1999, was that thought to be environmental effects, or was that purely fishing?
So the conclusion that I spent a lot of time thinking about this, and the conclusion that I came to was that it seemed to be environmental effects, because it was a recruitment failure that then just propagated through the population. It wasn't that there were a bunch of large crab that were suddenly fished out. It was just that there was a shift in the environmental conditions. Recruitment didn't come through for a good 10 years, and that means there's no big guys out. I can talk a little bit more about that. Okay. So,
Can I?
Yep.
Sorry.
No, you're good.
This figure here, I assume that there are also habitat effects. It's not just overlap.
Yeah.
Size overlap.
Totally.
Okay.
Nope. I didn't, just because it's tricky, and I was trying to get a rough index of the potential for cannibalism. I've got another variable within the models that I put together that is just the overall mature male density that could also potentially contribute to, it could potentially represent some of the pressures like cannibalism or resource competition that aren't captured in something that's spatial. So, we also know that they move around a lot, so it's like, it's difficult to, covariate construction is difficult for these different hypotheses because we've got a snapshot in the summer.
Okay. Yeah, I'll be honest, I don't know that much about crabs. I don't know how much they're moving around. I don't know that much about their habitat. Like,
yeah.
Is there space for them to hide?
So these guys,
when a thug rolls in.
Yeah, totally. Well, they will bury in the sand and muck for sure.
Okay.
The smaller guys, we think that the smaller guys move around less than the big guys. We know that the big guys will roam a fair bit to find mates. Yeah, it's difficult to go down there and watch what's happening. It's very deep and very cold.
Okay.
Hopefully we'll get some little automated robots down there chasing crab around sometime soon.
Okay.
All right, so given all that, it seems likely that a mortality event at least contributed to the decline we're seeing. And with that, my goal then became trying to estimate mortality over time and trying to link that to environmental variables, or link that to indices derived from the hypotheses we just talked through. And there are a whole lot of ways that you can do this, and I did this a whole lot of different ways, and I'm showing you one. Some of the basic decisions that needed to be made were what sort of model framework I was going to use, how I was going to compare the covariates to the estimated mortality, and what processes to allow time variation. And skipping to the good stuff, I'm at the very initial phases of all of this, I made an ADMB model and a TMB model to see if there are big differences in the estimated time series of mortality. It turns out there weren't. And because I'm more comfortable in ADMB and it's easier to debug, I stayed in ADMB. The covariate comparison, you could kind of think of two different ways to do this. You could build the covariates into your model and allow them to inform the variation in mortality or recruitment or whatever, or you could do some post hoc comparison of the covariates to your estimates of mortality with GAMS or some other regression-y thing. Ultimately, that's what I decided to do, and I'll talk about why I did that a little bit. And this is one of the places that I would love to hear disagreements or other thoughts on how to do this. I'm not including all of the things that I've tried, but I would be happy to try other things. And I also had to try and think about what processes to allow time variation in. Obviously, recruitment and mortality are the two that I'm super interested in, but given the potential for movement, the other hypotheses about movement that we discussed, it could be that selectivity or catchability varies over time. And I will tell you why I did not model that in just a bit. The model that I ended up using spans 89 to 2021 because our survey coverage was consistent there. It's only males, and it's only males that are not vulnerable to the directed fishery. I did that to try and exclude a big driver of the mortality dynamics of that fraction of the population and just focus on the fraction of the population that we lost. It's fit to immature and mature indices of abundance and their size composition data. I estimate initial numbers for immature and mature males, a mean mortality for immature and mature males, Gives around that, a yearly recruitment, and then the proportion of recruitment falling into size bins. These processes are things that we think we know a fair bit about: growth, survey selectivity, and the probability of having undergone terminal molt. So those are input processes. I can talk more about why. I think I'm going to talk more about why we think we know those. This is a very simple model, though. This in ADMB, this is the population dynamics. You've got mortality in the first part of the year, then they grow, then there's recruitment as they grow. Then you have those that grew to certain sizes mature, and then you take more mortality out. It's a very simple model. You don't really, I've already said which of these we fit to. These are a couple other likelihood components. We have a prior on M, on the average M, a penalty on the Ds so they don't get too big. This is just stuck in there for stability, and then a smoothness penalty so that the difference between mortality in a given year is not massive. Also just a stabilizing thing. So the growth data that we have comes from the BSFRF going out, catching crab that were about to molt, taking them back to the lab, watching them until they molt, and then measuring them before and after. So we feel like we've got a fairly good idea of how much they grow, and this is the size transition matrix, which just represents the probability of moving from a pre-molt size here on the y-axis to a post-molt size on the x-axis. And this determines the movement within the dynamics model through the size classes. The BSFRF also has done survey selectivity experiments where they took out Nephrops trawls and put them next to the NIMS trawls and compared what each of them caught. From that, you can get a rough idea of the selectivity of the NIMS gear. And each of these points are different years of experiments doing that. I haven't weighted these. Some of these have many more observations, but in fitting this GAM, they are weighted to the number of observations. And this OGIVE here is what was used within the model for survey selectivity. These are the probabilities of molting at a given size, molting to maturity at a given size. It varies a fair bit by year. These are input this data because we have measured this in the field. And they do that by measuring the claws of the males. If you've molted to maturity, you have big claws, so you can hold onto the females and fight with the other dudes. And the immature guys have smaller claws.
So we're welcoming questions.
Yes, please bring them.
On the selectivity looks like before.
Yeah.
Is there a hypothesis for why the monotonic is increasing? Is that like a habitat thing or anything? Or is there a reason?
It's a good question. I think if I were to toss something out there, it would be behavior related to maturity. I think these smaller guys.
More careless or something.
Oh, I think the larger ones are more careless. They're larger. It's harder to bury into the sediment, and they're also moving around trying to.
I mean, so then I guess that makes sense for why above 100 centimeters they're getting caught a lot. But why would an 80 centimeter ground be caught less?
Yeah, this
with
bump.
lower probability?
I have no idea. I think
Maybe that's just art.
I think it's probably an artifact. Yeah, I don't know, but it seems to be a fairly consistent signal.
I guess there's also like a weird gap where the red year line was really low, and the purple year really high.
Totally.
So maybe it's like what cohorts happen to be large during the year that overall selectivity is low or high, messes things up.
Yeah. Yeah, I think that assuming a time invariant selectivity for this is probably a tricky assumption. Yeah, and I'll talk a little bit more about this in later slides. But it's very, very difficult, at least in the simulation stuff that I did, it's very, very difficult to estimate time varying catchability, period. Like it just wants to fit the data That's what it does. Well, I'll talk about it.
Wait, can I ask you? I just like to understand. What goes above one? What does that mean?
I mean, if selectivity goes above 1, that means there's herding involved. Yeah, you can have a catchability that's above 1. Well, I mean, if you have a not logistic curve, I mean, you can think, if you just think about your selectivity at any given size, you can think about that as, so selectivity and catchability are tricky words, period.
Yeah.
They mean something when you have a logistic curve, in my opinion. When you start to move away from the logistic curve, it's harder for me to put sensible differentiation between the two. Does that make sense?
No, I just, yeah.
So it's also selectivity multiplied by catchability and then times the.
Yeah, so I guess the why, I'm struggling to understand what it's a product.
Yeah.
So why not just use the selectivity that comes out of the assessment?
Man, that's a can of worms. Because it is logistic and it doesn't fit these data. And that's a big can of worms. One of the reasons it doesn't fit the data is that the assessment has a very difficult time estimating this. And we don't estimate this, but on a yearly basis, but the time invariant curve here is, this is honestly a huge can of worms that I think that we should pass on. But this is an ongoing pursuit in the assessment with how to best treat these data. They are treated in the assessment as an additional survey rather than information that directly informs selectivity. So they don't fit these data. The selectivity curve that comes out of the assessment doesn't fit these data. But I think that these are the best available information that we have on the selectivity. It doesn't, in the big picture, I'm only modeling crab that are smaller than this dashed line here. In the big picture, it doesn't make that much of a difference to this analysis because scaling the population up or down doesn't impact the trends in mortality that you get. And that's really what I want to compare down the road. We can talk more about selectivity if you want to. That is a large can of worms, but I think we should do it later.
That's fine. It's interesting because I've never seen criminal data like this.
Yeah, it's tricky. Yeah, this has been. You come to the crab planting. It'll be good times.
I thought maybe just the acoustic team doesn't affect the correction too. They fish with two different nets.
Yeah.
So they're doing something similar. I don't really know.
Yeah.
Cody, are there plans to collect more years of data for that?
I don't think so. This is all done by the BSFRF. They are funded by profits from the crab fisheries. Yeah, and so they're in tough times,
Right.
and they've also pivoted to some other projects. So I don't expect to get any more data.
I mean, to Ian's earlier point, looking at this, it seems like the assumption of time invariant selectivity might not.
So the other caveat here that I have not well represented here is that some of these have very, very small sample sizes at a given size, and some of them have very large sample sizes at a given size. So 2010 is the one that has the best representation of this range of animals. I think 2009 has the best representation of this size of animals. So I could have presented these data.
What about the middle zone?
It's kind of, I don't think that any one year has the best.
I mean, well, 2010 definitely has that bump, which is so curious.
Yep. Yeah.
Okay.
Yeah. Come to the crab planting.
I'm good on the planting.
That's fair. Okay, so I think that it is an important question to ask yourself. Can you actually estimate time varying mortality at all with the data that you've got in the population dynamics model that you've got? And then add on top of that, can you do it with time varying catchability as well? I am historically suspicious of our ability to do this. I've written a few papers on it, particularly you've got confounded processes in the assessment. This one just said that if you fit the snow crab data with time invariant M and Q, time varying M, time invariant Q, time invariant M, and time varying Q, and then varying them both, and you get wildly different answers for what the trajectory of the population is, the status of the stock, and the management advice. So it seems like you really should know what's going on, in this case anyways, before.
Do you know which part of the model is monitoring is helpful? Like which part is hardly identifiable?
So the big changes in the stock really come from changes in catchability. Like if you fiddle with catchability, it blows your stock size up in 1 year and it can shrink it very quickly in the next year. So that is the biggest issue here. I've also done this in a simulation structure, and basically if you have a time varying process, if you have time variation, selectivity, growth, or M, you can soak up some of the variation resulting from that time variation with any of those processes. And that makes it tricky to understand if the improvements that you're seeing in retrospective patterns here, in this case, it's a result of just giving the model more freedom, or if you've actually nailed the right process. And it always has big implications for your management advice too. So plan was simulate some data with the crab model that I put together after having fit it to the actual data, and then fit a model to it that estimates mortality varying over time, and one that estimates mortality and catchability varying over time. And these are the results of some of those simulations. The red line is the simulated underlying mortality. Each row is a different CV on the simulated data, and then the columns are M and Q varying within the estimation model and just M. I think the big takeaway for me here was that you can estimate mortality fairly well when it's the only thing varying. You get some strange things when you allow Q to vary as well. And as you would expect, your estimates get poorer as your uncertainty goes up. Catchability, on the other hand, it's basically hopeless. It doesn't, the correspondence between estimated catchability and the underlying catchability was horrible, and got increasingly horrible as the uncertainty in the data increased. Another important thing to come out of this was that the scales of the population were off. It was difficult to get the scale through the recruitment coming in correctly specified, so this combined with the okay estimation of mortality, the poor estimation of catchability, really influenced my decision to only estimate total mortality in the model that I've used and not directly incorporate the environmental indices into the model. And the reason I didn't incorporate the model indices directly into the model was that some of them had an anchor or an actual quantity of stuff coming out of the ocean, some of them didn't. And if you can't get the scale of the population right that you're modeling, I didn't have any hope of getting the relationships between quantities that were anchored and unanchored to speak together properly. And also my initial attempts at incorporating the indices directly into the models failed rather spectacularly. I couldn't get them to converge at all, which I think is perhaps not surprising given the number of different indices. All right, so if you accept all of that, big picture, go for it.
Before you jump into that, just trying to think about how the different data sets are kind of playing together. These scale components change. Have you tried doing like a electron profile to see which is a conflict in the data that?
I haven't yet, no.
Yeah, but here, I mean, if there's so much uncertainty in scale, it'd be really interesting to see how the different data sets are forming that.
I think part of it is probably there is a size-dependent aspect to mortality, and I only estimate an immature mortality and a mature mortality, but that covers a large range of sizes. And at the small sizes, the recruitment comes, there may be higher mortality at the smaller sizes, but because of the way the model is set up, the same mortality is applied for all sizes across the immature animals and mature animals in a given year. I think that might be some of the disconnect between why you can't get the scale right with recruitment. I don't know. I haven't spent a lot of time thinking about it. once I saw that the mortality did okay, I was off to the next race.
Yeah, I guess I was thinking more from the original model too. You know, if you have some sort of conflict in the scale, it's going to be super sensitive to looking at the sample size or your CEs or whatever.
Yeah.
It's gonna be really predictable.
And I think that that's super important for the next step, because ultimately you'd like to do some sort of model of this that has the fishery data in it, and you can do something more stock assessment with it. But the main goal for me on this was just try to get a time series or a trend in mortality over time, so I can compare it to the covariates that I have representing the hypotheses.
Yeah, I think it's so useful for this because it'll give you a sense of the plausible in either situation that, for instance, the length comps will give you the signal hope.
Yeah.
Or not. But it'd be worth, I mean, it's easy to, it'd be worth doing.
Yeah, no, I don't disagree.
I have a question online from Jimmy and Ellie.
Uh-huh.
You're unmuted, so you can talk.
He likes to type.
He has his hand
Oh, he likes
raised.
to talk.
Yeah, well, is it?
Sorry, I don't have a question now. I'll save it till later.
Uh-oh, okay. So the next step after I got time series of estimated mortality was to try and relate them to some of the hypotheses that we had. And this resulted in a rather large GAM here. Some of these are not applicable to immature animals like discards, and some of them are not applicable to mature animals like predation or cannibalism. But the main idea was to try to predict mortality based on smooths of these, the covariates that I put together. And I did a few different sorts of stress tests of these models, leave one out cross-validation, 3-year out predictions where you just fit the data until excluding the last 3 years, and you try to predict them, or the last 2 years or last 1 year, and then a randomization exercise. So over here in the red are the estimated time series of mortality from the models, immature on top and mature on the bottom. The dark blue lines are the model fits from the GAMs with all of the data in them, and then the lighter blue lines are excluding years of data behind. So the deviance explained for these models was fairly high. It was over half for each of them. And in both of them, the temperature occupied by the given sort of critter by maturity state and the mature population density were consistently important predictors of the maturity. And what's going on over here is this is a result of the leave one out cross-validation stuff, where I tossed a data point out, I fit the model, I recorded the deviance explained and which of the covariates was important, and crossed all of those replicates, temperature and mature population are most often important in predicting mature or mortality. So the randomization stuff was just, I think it's worrisome when you've got a model that looks like this and you've given it a lot of flexibility, that the fits that you're seeing here are a result of the flexibility. And to address that, I randomized the covariates. I refit the model, recorded the deviance explained, and then I did this 1,000 times, which is the this histogram. I identified the 95th quantile within that histogram, and then I tried to see, all right, hopefully I would see that the observed deviance explained was outside of that, which is what I saw here.
Sometimes you basically put white noise covariates in to see the null distribution by chance.
Well, I resampled the covariates within a year. So I just basically shuffled all the data for a given covariate. I refit the model.
Okay.
Yeah. I'm sure there are probably other things that you could do, but these were things that made sense to me to make sure that it wasn't because I was giving the model too much freedom, and that trying to identify points where trying to make sure that there weren't specific points that were very influential in the analysis. Okay, so before I get to the explanation for what's going on here, I said that there are several questions that I get about the causes of the collapse. One of them is, are you sure it wasn't cod? I wanted to show this figure quickly. If you take the numbers at size in 2018, you project it forward to 2019 by applying the growth transition matrix, taking out our average natural mortality, and then taking out the catch as well, you would get the blue line here. But the red line was the observed, and these are the numbers of crab at size. So if you remember back to me saying that cod generally eat crab that are under 55 millimeters carapace width, that's this line right here. That means that a good chunk of these crab were just too big to be eaten by cod. And that's even more true in 2021 than 2019. I'll jump over that one. We're getting on in time. Jump over that one. Another question I get regularly is, are you sure it wasn't trawl bycatch? I think it's very difficult for me to reconcile the fact that we just saw the largest cohort ever come through that had to exist for 8 years in the Bering Sea, subject to very similar trawl bycatch over this time, with the idea that it was that the trawl fleets were responsible for the collapse in 2018 and 2019. It's also hard to reconcile the 10 times bycatch in the early 90s from what we saw here and not seeing any spectacular collapse there.
I had 2 questions from Jim. Do they become vulnerable to predation after molting, as in a soft shell effect? Does this get picked up in predation data for cod?
It seems like they'll eat them whenever. I mean, they're particularly vulnerable to any kind of tampering after they've molted. They're relatively hard shell well, they are hard shell in the summertime when they see them in the survey. Molting happens earlier in the winter, and we're seeing a lot of crab and cod stomachs in the survey. So, yeah. What was the
How long
second?
does it take for the shell to harden?
I don't really know. I'll look that up and get back to you.
It's kind of a very small fraction.
You would think. You would think, yeah. It wouldn't be a very evolutionarily wise strategy to be running around with no clothes most of the year.
So some of the media reporting that I've seen on this have mentioned the possibility of IUU fishing.
In the Bering Sea?
And that's where the 500 million crabs have disappeared to. Is that, I mean, even a possibility that
it's not even
dark
something.
boats are coming in under cover of night and
No.
fishing up all of these
No.
crabs?
I mean, not one that I have seriously considered, and I don't think so. That's bad, but it's hard to say absolutely positively no, but I don't think so. It did make me think of something. I forgot what it was.
Hold on, Jim has a follow-up.
Yeah.
About predation. Jim, you can write it, or I don't know how you're.
Speak up, Jim. We heard you before.
He's probably at a bar right now.
Okay, Jim, I think I unmuted your second attendee.
Doing assessment at a bar, I'm sure. No? I'll talk for a little bit, and if you have your question, type it or whatever. Okay, the other question I get is, are you sure the crab were actually there? And the first thing that I point to, and I try to answer this question, is that it wasn't like there was a single survey tow that was really driving this big apparent cohort. There were wide swaths of the Bering Sea where there were just tons of crab. And this was really corroborated by other pieces of evidence, including the discards, which went way up as that cohort worked its way through. And the discards go up because there are a ton of small crab in the population. They're getting into the pots, and then when the fishers bring them up, they got to chuck them overboard. And you saw a similar signal in the trawl bycatch.
I have a quick question from Christine. Do you have a good estimate at how fast the crabs walk?
I don't. There have been some movement studies done where the larger crab can move quite a ways.
When they do those,
but it's over
studies, the
time.
molting growth transition matrix, they should get some like crab races.
Yeah, yeah, totally. So I don't have the figures off the top of my head, but there are tagging studies where they have tried to sort that out one way or another. I can send them to you when get off of the interwebs. All right, so back to the central question: how could high temperature and increased mature density result in mortality? Those are the two big covariates that came out of the GAMs that we put together. And luckily, we've got some information from Foyle and Odor back in 1989, where they went and caught some crabs and they stuck them in different baths, and they measured lots of things about them at different temperatures, like how much they ate, how much oxygen they were using, how much they moved around. And this figure turned out to be central. This is from their paper. Turned out to be central to the explanation. So immature crab usually sit in water that's close to 0 degrees Celsius. But in 2018 and 2019, the temperature that they occupied was closer to 3 degrees Celsius. So there's roughly a doubling of the caloric requirements required from that change. And if you put that piece of information together with the historical temperature occupied and the historical abundances observed, you can get a rough idea of the caloric requirements in the Bering Sea for this portion of the snow crab population. And the big takeaway here is that, and that's what you're looking at down here, the big takeaway is that from 2017 to 2018, the caloric requirements quadrupled, and this went up to a point that was roughly double the previous high seen back in the 90s. And if you look at the weighted size of crab while controlling, so you fit a GAM to the weighted size of the crab, which are each of these little dots that are observed on the survey, based on the temperature that it was occupying, the size of the crab, and then adding a year effect. The weighted size of a 75 millimeter crab was 15% less in 2018 compared to 2017. Piling on pieces of the puzzle, the population was also concentrated in the smallest spatial footprint that it's ever been in 2018, represented by the colored dots here. All of the gray dots are the maximum extent of the population historically. And this is the time series of how many of these main survey stations had a snow crab. So if you put all that together, you got this increased metabolic demands, changes in weighted size, decrease in spatial extent. It suggests to me that starvation played a role in the collapse. And
sorry, just to piggyback one slide.
Yeah.
It looks like the bigger effect was not the temperature being hotter, but I mean, it's both. It's the abundance.
Yeah.
They're done in by their own success.
Totally. So there have been periods of time where it was similarly hot for the mature animals anyways, not the immature animals, but for the mature animals.
Yeah, I see now.
They had seen similar temperatures, but it's never, and that's actually a very important point that came to light in the rebuilding plan, is that if we're trying to understand what we expect for mortality in the future, it might be hotter, but there aren't going to be as many crab out there as there were. So we probably won't see mortality events on this scale in the near future anyways. And that was a big decision point that we had to make in the rebuilding plan. So if you put all that together, this collapse appears to be one of the largest reported losses of motile marine macrofauna attributable to marine heat waves that I could find in the literature, which I think is kind of bonkers.
Sorry, what are the non-motile?
Well, you can think about like shellfish, like there were those big shellfish kills or corals or something like that. I don't know if you call corals macrofauna. I don't know. Does it count? I don't know. I put a lot of qualifiers in there, so the statement might have some chance at actually being true. Yeah. So that's at an hour. And yeah.
What is the main prey of, especially for every
They'll eat pretty much anything they get their claws on. They eat a lot of polychaetes, but they are generalists. They just go and sift through the sediment and the substrate and eat whatever they find that they can fit in their mouth.
Is there any data on whatever they find?
It's so yeah, there are, and that was one of. But it's from the trawl survey, and it does not sample the benthos very well. But it doesn't
it's
seem
about the same every year.
Yeah, and that's true. Yeah, totally. But the trends in the sorts of things that it eats and have not declined sharply over that period of time, which is interesting. I didn't end up including that in the analysis on the suggestion of the people that collect those data because of the uncertainty around how well it actually does.
Because you say that starvation is probably the main reason. So as far as I know, probably I'm wrong. If the metabolism increases because of temperature, but if still there's enough food in the environment, I think starvation could be the reason.
Well, could be. It could be that they're in the wrong place. We don't have a good measurement of the food is the ultimate answer to that question. And I think it would be really fun to do a more consistent like benthos grab in addition to our trawl surveys, so we knew what was going on in the benthos a little bit better. But yeah, I agree. That is an unsatisfying point for me personally within this paper as well, that I don't have a good number to put on prey availability.
Do you know how important is the light intensity for the prey capture of every fish?
I mean, let's see, they're down at 100 meters depth, so there's not a lot of light there, period. And it's like, my guess is no, and part of that is the depth, and part of that is that half the year it's dark up there anyway. So if they were going to if light was important and they couldn't make it through that year where it was dark, they probably, or the half a year where it was dark, they probably wouldn't make it anyways. I don't know. That's the first time somebody's asking you that question, so that was an off the cuff answer.
To detect the prey environment, they need light because they're fish. It could be a lot of prey in the environment, but if there is no light, they are
That's interesting.
I was thinking about something similar.
Huh. Yeah. And are you speaking of their, like, where do they live? What are they living in shallow waters? Is that what's going on there? Yeah. The larvae.
They spawn on the bottom, the ocean bottom, apparently they hatch.
Okay.
So there's going to be a point when the light intensity increases, so they can start to hatch.
Gotcha.
the light is spread out, if there is no light, they cannot.
That's interesting. So crab go through a larval phase as well, but they don't move very well during that larval phase. And then once they go up and they just kind of float along, and then they settle and they bury under the substrate. And usually that's at a pretty good depth.
They're not really visual predators, right? That's not what you described.
Not, I mean, this is also not, I haven't gone and sat and watched crab. Not my area of expertise, but I guess it's not my expectation that that's a lot of, yeah, I don't know, so
For the folks online, that was a question about whether or not light is important for larval crab.
yeah, I promised to repeat the questions, but I haven't repeated any of them, so sorry, show up next time.
I have one question from Paul Spencer. If it was starvation, wouldn't you expect a bigger decline in the weight at size, i.e. condition?
So putting that weight at size piece into this was, I had to wrestle with some crab biologists to get that in there anyways. Because there are other studies out there that say even through starvation, the weight at size doesn't change a lot. So I guess they were surprised at this 15% decrease in weight at size, and the place that they get these starvation exercises or studies from is strange or interesting, maybe not strange. They pack snow crab into boxes like they would to ship them to other markets, and then they just leave them there. And they let them starve for a long time so they can weigh them and see how long it would take for the meat quality to decline. I think they generally wrap them in wet paper or something of the sort, but they didn't see big changes in there. The thing that they do see big changes, they didn't see big changes in the weight at size. They do see big changes in the hepatopancreas, which is some organ that I'm not clear exactly what it does. But that's the thing that the biologists wanted me to look at, but we don't have good data on that.
How long did they pack them in boxes for?
I think it varied, but at least 4 months. I mean, the tricky thing there is also that they don't move around. They're just kind of sitting there doing nothing. And if you are in warm waters, both running around trying to find food, running away from predators, finding mates, the story might be a little different. And that was the justification I had for actually putting that slide into the paper.
The fraction of crab weight is their shell.
What
I don't know the
fraction
answer.
of crab weight is their shell?
Thank you. I don't know. I don't know.
I have another follow-up.
Probably
question.
a good fraction.
What happens to a starved crab? Would that be picked up by the survey?
What happens to, would a starved crab be picked up by the survey? Oh, so you mean like, why aren't we seeing a whole bunch of shells of dead crab in the survey? Basically, something like that?
I think it's in the survey how.
Or the fishery.
I don't know if they can tell that the crab are starving or not, but they can tell if the crab is dead or not. And the justification, so I asked this question to the people that actually go on the survey. And it's like, if all these crab starved to death, why don't we see a bunch of crab shells out there? Why don't we see that? And the answers that I got were that, so if you think about it, even in normal years that aren't massive mortality events, there are a ton of crabs that are dying in the Bering Sea. It's like, I don't know, a third of the crab are dying in the Bering Sea. And they very rarely pull up shells of crab in the Bering Sea. Sometimes it happens in the northern Bering Sea where there are very cold temperatures. But the answer that I got was that they think that the shells decompose relatively rapidly down there. because there are things that will pick them apart. And
More so when the water is warmer?
yes, yep, yeah.
So have the fishery, like in, I guess, 2021, like, did they notice any change in like condition of the crab?
In 2021, it was hard to find crab.
Yeah.
Um,
Yeah, was
I-
the
they-
meat quality bad?
No, they were in 2021. They were okay. There were very few crab caught in 2021, and I think one of the things that we also have to remember is that the biggest crab, which are the ones that are caught in the fishery, are probably the most insulated from some of these issues because they're the most motile. They can move different places easily.
They might be the ones spraying up. in the-
Yeah, totally. Totally, yeah. And I'm sure that happened in some respect.
What
But
about from 2020 when there was no survey and so the fishery is really the only source of information? Like anecdotally, did they make any mention of there were less juveniles that we were throwing out of our pots or?
yep, so this figure right here shows it.
Okay.
So this is 2020 right here. And the amount of discards that they were chucking out went way, way down.
Okay. So that's like all that we really know about 2020.
Basically, yes.
Nobody said anything like, oh yeah, the crab they were catching are crab.
Yeah, no, in 2020, they're actually pretty happy with the crab that they were catching, but they're also fishing way farther north than they usually do in deeper waters. But they were having some pretty good fishing. It was just they were fishing on crab that they don't usually fish on. And that was one of the real, like I sat on this paper for a year because I wanted to make sure that the crab were actually gone. Like it would be, we had the 2021 survey where there weren't a lot of crab, but they were saying that there were a ton of crab in 2020 when we went out to fish. But now with the 2022 survey, it looks like there are really crab aren't there.
If you go to your 15% curves slide, seems like the difference was more for the smaller crab than the bigger crab. So, I don't know exactly what size they're catching, but you wouldn't necessarily notice the difference between a 100 gram and a 510 gram.
Right.
That's not something.
Yeah, totally.
Whereas maybe
Totally.
47 millimeter crab, it's a much bigger difference relative to its size.
Yeah. Let's see. What?
I want to know what happened. Or sorry, I want to know what we do now. I believe you.
So, okay. Do we, go ahead. Yeah, please.
Did you look at dissolved oxygen as an explanatory variable?
No, I didn't. And the reason I didn't is that in the studies that Foil et al. Did, they said that the crab were totally good on oxygen up to much higher temperatures than we are observing. And in general, the dissolved oxygen is fairly high in the cold waters of the Bering Sea. It's not well within the physiological requirements of crab. So these are scheduled from 1 to 3. They don't always go from 1 to 3, right?
You can go as long as, well, you can go.
I went 2 hours.
You went 2 hours? Okay. Well, I could go 3 hours. But I won't.
It's not a competition.
I won't. Okay, so the next big question that we've been thinking a lot about is what do we do now? And there are kind of 3 time scales to think about that. In the near term, we've got yearly quotas to set. We have set in OFL. We've got rebuilding plans that we have to write. Medium term, we've kind of got this, we may run into the question of what do we do with reference points when productivity is changing over time? Are there circumstances under which we should change them? Are there circumstances under which we shouldn't? And then long term, I think we need to think about spatial shifts out of the eastern Bering Sea into the northern Bering Sea. And I'm going to talk about a few pieces of work related to all of these now. So by law, we're required to do rebuilding analyses when a stock is overfished. Magnuson-Stevenson's, the MSA tells us this. And the basic idea is that we have to identify different trajectories of rebuilding under different strategies. And we do that with projection models that, for snow crab anyway, that have the acceptable biological catch, only bycatch, no fishing, the state strategy with bycatch and without bycatch. And each one of these lines represents the median for one of those strategies under different assumptions about the future productivity of the stock. And the two main axes of that productivity that we considered are recruitment on the columns and natural mortality on the x-axis. And the so for recruitment, this is something that, for better or worse, I spent a lot of time thinking about. We were able to pull from a paper that I wrote with a bunch of other folks looking at predictors of recruitment for snow crab, and it turns out that ice and the Arctic oscillation appeared to be related to snow crab recruitment. And going forward, we expect there to be less ice in the future, which for snow crab recruitment is a bad thing. So based on this paper, we chose a future for the projections of the rebuilding analyses that has lower recruitment than the other option. The average mortality scenario, this comes back to what Ian was asking about, or the mortality scenario that we use doesn't have these punctuated mass mortality events in them. And the rationale for that was based on the analysis that I just presented, that temperatures may be high in the near future, but crab densities won't be, so we shouldn't expect these large mass mortality events. Ultimately, I think it would be fun to incorporate the fishery into the model that I presented earlier and go back a little bit further. And I'm working on that. I've got it fitting to the survey stuff with the larger size classes in here, and then the catch data as well, with estimates for fishing mortality, immature mortality, and mature mortality. Hopefully we'll connect all of those to environmental indices as well. The tricky thing and the rub in here is that explaining what happened in the past with environmental indices and trying to project that into the future are two different processes, because I've got all of this fine-grained spatial data in the past, but I don't have that in the future. I don't know of any way to project that into the future. So I have to refiddle the covariates included here. So this is, I think, the thing that I'm most curious to hear opinions on and thoughts. In the medium term, we've got this, every year we set management advice. It's based on reference points, and our reference points are calculated over a given period of years. And if we're running into a future where the productivity of a stock changes, the MSA suggests that we should change our reference points to reflect current environmental conditions. But there can be big impacts of changing your reference points. And I'm going to talk through some of these impacts right now, and then hopefully hear some opinions from you. So the general, I'm going to walk through a very simple simulation with a production model. And if you know me, you know I don't like production models very much, but I'm doing this grudgingly anyways, because it illustrates the point well. The gray line is a simulated stock moving through biomass and harvest rate space. So each year it goes along. This is year 5, 15, 25, 50. It's behaving according to effort dynamics that Thorson wrote about in 2014. And just a simple production model is underlying the population dynamics portion of that. So its carrying capacity is at 1,000, which implies its BMSY is at 500. So, and then also I should note that this dashed line is a a harvest control rule that determines the fraction of the FMSY, which is up here, that's applied at lower biomass sizes beneath BMSY, which I think is one of the best inventions of fisheries management. So if you go through a spot where you've got a change in productivity, the carrying capacity declines from 1,000 to 500, that implies that the BMSY is then half of what it was. And this is then the resulting harvest control rule based on that new BMSY. As a manager, when you see this change, you have a decision to make. Do we change our reference points to reflect the new productivity of the system down here to B, or do we maintain this old, the historical productivity of the system as our target? And which of these you choose has a fairly big impact on the harvest rate applied to the population and the amount of biomass that's left in the water. So if you change your goalposts to B, you leave less biomass out in the water, and you harvest the stock more intensely. You get roughly similar yields. It's a bit higher than if you don't change from A. But if you keep it at A, you keep more biomass in the system, you apply a lower harvest rate, and then get slightly lower yields. So just to restate that, if you adjust your management targets to reflect a decreased productivity, this will result in a higher exploitation rate on stocks that are experiencing stress under climate change, which seems like maybe something that you wouldn't want to do. But maybe you would, and I think that is a good discussion point. Being naturally suspicious of production models, I repeated this exercise in a snow crab centric model that has ice dynamics driving recruitment, and did a very similar thing. So either you use the historical period of recruitment to calculate your target biomasses, or you use something starting in the future when we've got new conditions. And the same sort of pattern popped out. If you change your reference points to reflect these current less productive systems, you will harvest the stock harder than you would if you maintain your historical reference points. You'll get similar yields under both strategies, but you will leave more biomass in the ocean if you're using the historical or the status quo rule. And recruitment isn't the only process that could be affected by changing environment. It could be growth, or it could be natural mortality. So I did the exercise again, changing decreasing growth, which would represent a decrease in productivity, or increasing natural mortality, which would also be a decrease in productivity. And you get the same outcome. If you adjust your expectations for productivity and you use the lower productivity regime, you'll harvest the stock harder than if you try and manage to historical productivity. And there's a double whammy with growth and mortality here. These are the harvest control rules for when recruitment changes. The fishing mortality rates do not change. It's just the biomasses. But when you adjust either the growth or the natural mortality, the target fishing mortalities also change. So there's a double whammy of letting the stock go down lower and also fishing it harder. So both of these have been in a single species context. I'm thinking about one species at a time. I think I know which direction it's going, but if you're thinking about this at a more ecosystem level or a global level, it might be useful to think of many stocks at once. And to do this, I pulled data from the RAM Legacy Stock Assessment Database, and these are all of the individual stocks in the analysis with the production curves associated with them. I simulated shifts in carrying capacity randomly up or down to each of these stocks. I projected under harvest control rules that either shift to the new carrying capacity or maintain the targets associated with the old carrying capacity. Did this 100 times, so the big stocks didn't always have shifts up or shifts down in carrying capacity. And then I compared the biomass and yield. These shifts in carrying capacity were designed such that the yields on average would be the same in the projected periods. It's just there would be winners and losers of climate change. And I guess the big story is that the yields under each of the different harvest control rules are very similar at the global level, but more biomass is left in the ocean under the status quo rules that are aiming for targets that are, I guess, representative of historical productivity. And why this is really makes more sense when you look at the stocks that are declining in carrying capacity or increasing in carrying capacity. And for those, when you adapt to the new conditions, it depletes the stocks to a much lower level than it does if you don't attempt to adapt to the new productivity. But you get very similar yields. For those that increase, you end up at the end of these with almost identical biomasses and identical yields out of them. And this is just a result of the balance changes in carrying capacity and the fact that because there wasn't an impact of climate on the fishing mortality rate, you're applying the same fishing mortality rate across the board in the future. Okay.
You're running this long enough to get through the transitory periods?
Yeah, so I mean, you can kind of see the transitory periods right here, and then these all level out. Yeah.
Yeah, it's true. It should be pretty quick.
Yeah.
And to me, this means there's an artifact of a particular production model, but this kind of is fishing too hard. If you were to compute some kind of maximum economic yield, you'd be far better than leaving more fish in the ocean. You're going to get similar yields for half the harvest rate.
Yeah. You're Australian.
Yeah. Well, you know.
That's true. That's true.
I have a comment from Jim. What if we just forget harvest control rules that are tied to reference points altogether, adopt a management procedure, and use performance statistics that allow dynamic reference points, among other things? The challenge will be to differentiate climate effects with shifting baselines as part of the performance statistics. This avoids the estimation issue of knowing what a good reference point is in the current year/estimation paradigm, and instead reflects what the stock trend is doing with relevant performance metrics, acknowledging non-stationarity potential. You can also unmute.
He can? Well, what's a relevant performance metric?
Well, I think you do that through whatever you think is happening with the environment. So like you have really outrageously different warm conditions. Obviously, it's not going to produce, well, maybe it's obvious that recruitment will be different during that period. And if you have some climate model that is projecting it, you could kind of index it. I don't know. I just worry that we're too wrapped up in a fixed harvest control rule that pretends that we know what FMSY is and what BMSY is.
Yeah, I mean, at the end of this, I agree 100%. And that was kind of my takeaway. I don't know that we're going to get there today, but I think that it's been a rough couple of years. A lot of my assumptions and thoughts about the way that things should work do not, I no longer hold some of those assumptions and thoughts about the way that things ought to work with respect to harvest control rules, population dynamics, fisheries management in general. And I think that it's one of the really cool things for me about working with ACLIME is that these are sorts of things that we're trying to ask, but it's also, there's this weird line that you have to walk given a fairly rigid council system, a fairly rigid MSA, I don't know, declarations. You've got rules from the MSA that you have to follow. It's also tricky that the MSA has been demonstrably effective in curbing overfishing and reducing overfish stocks in the United States. And to think that we've got to wholesale change all of that, I think is a difficult pill to swallow for many people. And maybe you don't need to wholesale change it all, but.
But you could say that the Ray Hilborn point of view is that we're also underfishing lots of fish stocks, given that. And I guess the point isn't that, I guess what I'm saying is that, yeah, we're in a very rigid system, but I think there's flexibility that you could pick a management procedure that's been tested against the types of simulations you're doing, not the production model, but perhaps the other one, where you're indexing the stock and, if the, it's responding to data, the quota can change based on the rule, and you can show that from kind of the shit happens model, it's robust or not, and proceed that way. I guess, yeah, I'm at odds with trying to tackle this question of what's BMS wide this year problem.
I hear you. And I agree. I think even if you go down the route that you're suggesting, you still kind of run into the problem of, which I don't know is necessarily even a scientific problem. It might be just a social problem of, we did something somewhere else. It impacted the stock here. It's now less productive. Do we just say this is the new normal and fish it as we would otherwise, or do we try and back off the stock and let it recover somehow? And I think that's even in your, I think anyways, the way that I'm understanding what you said, that even in your idea, that decision is the central one, and I don't have a good answer for how to make that decision.
Well,
Except for my committee, and that seems terrifying. Ian raised his hand. Did you have something? What was that, Jim?
All right, just follow up real quick. But do we really know that we did something that caused this to become less productive? I guess if that's the case, if we know that, then yeah, I think our actions should respond to that. But I'm unconvinced that we know for sure. I mean,
Are you convinced that some environmental drivers changing productivity?
I'm fairly convinced that the marine heat wave had a very bad impact on the stock, and I expect things to continue to be warm going forward. And I mean, I think the consensus is that the warming conditions are something that we did elsewhere, and I don't know how to reconcile all of those points. Ian had a hand up.
You talked about how bycatch in the bottom trout fishery, even though it was all many millions of crab, didn't amount to, couldn't explain all the missing crab. But in your rebuilding analyses is like a no fishing scenario. So I guess I'm curious about sort of that conversation about who feels the pain. Obviously the crab fishers are feeling the pain no matter what, but is it being spread to non-target fisheries for these bycatch?
Oh, it's tough. So this is a very popular and contentious conversation at the council. In these, the green line for no fishing lies directly over the top of the only bycatch scenario.
Okay.
So in these, it's tiny, but there is likely some fraction of bycatch that is unobserved, and that has been a sticking point for many of the crabbers in trying to understand what that is, because they see these big trawlers going over the grounds that they fish crab on, and they know that they're bonking into the crab's head and probably killing some of them that we don't.
Unobserved being maybe killed by the same nets that are being observed, but not, it doesn't.
Right, it doesn't come in.
Right.
And I think that there's a fairly, there's been a fair amount of effort trying to understand what's going on there.
Those robots that are
Yes. Yep. I would like that. I've said for a while, we need to partner with NASA to get some of those little rovers that they stick on other planets. Like they're going to go to ocean planets, right? Eventually, you need to test them somewhere. May as well be the Bering Sea. They've actually done that they've got little robots that go under the ice, like they attach themselves to the ice and skitter along. Yeah, maybe. I think they did that in Antarctica though.
I have a question. Have you looked at any climate effects in the A parameter of the SPR relationship or not carrying capacity? Any sort of?
No, I haven't, and I'm not going to because I don't like production models. This was done mostly to as a, I don't know, trying to provide some context of it. I think that this is where things should happen, is in models that differentiate between the different population processes.
I have another question. Actually, I have one question first. Why was the target fishing mortality rate, FMSY, in your fishing biomass plot higher when assuming the lower growth rate? Should FMSY not be lower if the intrinsic growth rate is lower, which could be due to a lower individual growth rate or a higher natural mortality?
Who's asking this?
Tobias.
Okay, good job. Gold Star, the reason is that these are, right, I think the easiest way to answer that is that these are SPR proxies. These are F35%, not FMSYs. If you want a history on that, I would go look at Chris Legault's paper on the unintuitive directions of catch advice coming when natural mortality is assumed to change. I think that was in ICES or something like that. It was a good paper.
Paul wants to talk. Paul, you should be unmuted.
Oh, hi, Cody.
Hi.
Yeah, so I was the one that asked about the A parameter, but it was more of a kind of a general comment. And what I was getting at is the kind of what you just said about the SPR rates. You know, when I think about climate change and productivity, I think of you know, of the rate of things, you know, the rate of productivity of stock. For example, the recursive spawner and those kind of metrics, which I think you might get at more with a FMSY than SPRs. So I would think that not only would you have a smaller carrying capacity if climate was affecting productivity, but you'd have a smaller rate of production in the stock too. So both those things would be moved at the same time, I think.
Yeah, I hear you. I think one of the stumbling blocks there is that I don't know if I can point to a stock that has a stock recruit relationship in the Bering Sea that I could calculate FMSY from. So yeah, I think that for me, that was the tricky part.
Yeah, I guess there's only one tier stock in the Bering Sea, I think, one or two.
Yeah, right. Yeah.
But in
okay, well,
okay, go ahead.
No, go ahead. Go ahead.
Well, I was thinking in simulation mode, like a lot of what you're doing is in simulation mode. I mean, you might be able to get at that, but yeah. I
agree. But if you simulate something that you're not actually observing in your systems, I struggle with this a lot. Like making your simulations applicable to your system by reflecting your observations in your assumptions. Yeah, it's a tough one.
Yeah, it seems like in the, you know, in ACLIME group, at least I kind of struggle with this because, I mean, when you move the goalposts, you know, if you expect that they're never ever going to go back, I mean, at some point you have to kind of imagine stock you have, not the stock that you wish you had. You know, but if you think they might come back at some point in the future, just on a longer time horizon than you might care for, you know, then there's a question of how much do you want to move the goalposts?
Yeah, no, I mean, I agree. It gets really squishy because then it's like it turns into opinions and risk analysis, and It's hard. That's basically what I've taken from all of this, is that it's going to get so much harder once we see stocks changing in productivity on a widespread scale. And I think that the thing that I wanted to say here was just that I've spent a lot of my time in the last 10 years trying to look for environmental drivers of productivity of stocks and incorporate those into management. And at the end of all of this, I still really like trying to understand why stocks are changing, but it's been a difficult pill to swallow, that if you incorporate environmental drivers into your assessment and management, that under the current rules that we have, you will end up fishing stocks that are under stress and are declining in productivity harder than you would by not doing that. And it's like the very first paper I wrote said that in it, but it's taken me 10 years and a fishery collapse to kind of process it and get to there. And I don't know where to go next, because once you move out of this MSY framework where the environment can be guiding the productivity of the stock, things get so much squishier and so much more into the social realm where you've got to make these decisions that it's hard to give a simple explanation as to why you're making them. So it's been tough. Yeah.
So, you know, that one, your production example where it goes from, you know, episode goes from 1,000 to 500. I guess it's just kind of philosophically, you know, I feel like we are trained or intuitively think that the 1,000 is the right one. But like, how do we know that it wasn't 500 for 100 years, and then we have a weird 20 years right when we started fishing, so we have this like really poor perception. So like, how do we make a value judgment on something where we kind of arbitrarily started fishing, right? Like our perception of what the stock is, or Paul says what we want it to be, you know, it's completely arbitrary. So how do we wrap our heads around? How do you think about that?
Well, first, I don't know that it's completely arbitrary. It is based on the period of observation that we've got. I mean, that's what we've got.
What if we started fishing 100 years
earlier? Yeah. That's part of my fisheries existential crisis, buddy. That's that's part of the squishiness that I'm uncomfortable with, and I don't have an answer for you. I was hoping that I'd come here and you guys would be like, "This is the answer."
Well, I mean, what's wrong with saying we just have to be accepting of that, chill with that? You know, the environment changes, the ocean's very dynamic, and over a long time scale, the relative abundance and productivities of these stocks are going to change. Nothing wrong with that. We just try to keep up. What's wrong with saying that?
What feels wrong to me about that right now is that the reason that productivity is changing, in my opinion, is another source of human imposed mortality, essentially.
Right.
Yeah. And we don't know how well we are or are not going to remediate climate change effects. It could be that we get our shit together and CO2 emissions go down and the world goes back to, I don't know, a cooler state. It could be that we're not going to do that. And we're in this weird little limbo area, I think, right now, that it feels wrong to give up on stocks that were adapted to the way it was 20 years ago, or roughly 20 years ago and before. I don't know. It's also kind of a squishy opinion. It's not like I can see the other side. This is what we've got now. This is what we should deal with. But it doesn't feel great to me, given the backdrop of climate change.
So you just shift it if it goes up, pay goes up, fish harder, goes down, you leave it.
Well, if K goes up, it's not a big problem because you've got once you get past that kink in the harvest control rule, you're still just applying the fishing mortality rate. That's
But you actually, under an adaptive rule, you fish less hard.
right.
But I mean, you adjust.
But hopefully you'd get there quickly and you'd get to be able to get back to your.
I mean, you could have so many, like in your simulation, you have like a symmetry. You have a symmetry where you move it or you don't. Like you can move it if productivity goes one way and not move it. Be like conservative.
I feel like, on the one hand, I kind of like them to be chill with it. The world's always changing. We just need to adapt to the world we live in. But what scares me is the idea that, like, what if we're wrong and the productivity didn't go down and actually we just had higher mortality measure because our models are wrong.
Mm-hmm.
And so then you get into this like death spiral where you kill more fish than you think you are. You think the productivity's gone down, and you say, oh, well, instead of ratcheting down catch, we're just going to keep harvesting at the same rate because that's okay because it's the productivity that changed, and then just spirals down and down.
Yeah, I can see that.
So it seems like some amount of let's ratchet back fishing and see how far back up they come.
Yep.
Would be a useful exercise. And in the case of like, northern cod in the Atlantic, there's lots of time to see, oh, they're not returning to the way they were. The world has changed.
Yeah.
But
yeah, we've got.
It's only been a short time.
Right. Yeah.
I mean,
totally.
It seems like a great hypothesis, but why not?
I agree. Yeah.
But the one totally separate question is in terms of like adaptability, because we're on the West Coast where we think about, trying to estimate biomass back to the 1800s. We look to Alaska where you have this magic rule that 1977 is when the ecosystem changed, and that's the only time period we're going to focus on is everything after 1977 because it was a different world back before then. So what if this is the next 1977? If you can declare that your same rules only apply to this period, why can't you get another break in time?
That's fair. It's also super scary to me. Yeah. Well, I mean, there was a massive reorganization in the ecosystem.
I mean, I've seen the aired photos.
Yeah.
But we also have much less good data before that.
That's true too. Yeah, I don't know. It's a wicked problem. It's tricky. Let's see. Where are we at? We got 10 minutes. Okay. I guess I'm going to talk briefly about spatial shifts because there are a couple of cool papers. So we haven't been surveying in the Northern Bering Sea consistently until 2017. There are a ton of small crab up there, but they never ever get big enough, or at least since we have been observing them, they don't get big enough to be of interest to the commercial fishery. And these maps are the years for which we had Northern Bering Sea data up to 2021, and they show the commercially sized crab or the distribution of them. And there's just really none of them in the Northern Bering Sea right now. And this has been my justification for basically ignoring the Northern Bering Sea at this point, even though there are a lot of crab up there. It's because there's on average less than 1% of the commercially exploitable crab are up there.
Did the small crab move south?
They do. We don't know how much they move from the Northern Bering Sea though. So we know that, like, if you go back to, so if you go back to this photo, this is where there were tons of, this is where all the small crab is, right here. And eventually they make their way down here to be fished in the fishery.
Right,
but I don't know where these small crab go.
Okay.
They might end up down here. They might stay where they're at, and mature there. It's much smaller sizes. They might move into Russia. They might go north. We've got 5 years of data, so we don't really know what they do. But even though there aren't crab down here or up here yet that would be commercially fishable, it's likely that there may be fishing opportunities opening up there in the future if a few key things happen. And Daryl Maloney is the assessment guy. He's the crab guy over in Newfoundland. And he wrote a cool paper that compares the Alaskan stocks to the Newfoundland stocks and the Gulf of St. Lawrence stocks, looking for environmental drivers of the exploitable biomass, and looked at long-term prospects for populations in other places around the Arctic. So we've got our population in the Bering. There are some over here off of Japan and Korea. This is the Newfoundland stock. The Gulf of St. Lawrence is in here. There's also one up here off of Norway and Greenland. But the thing that I took away from the paper that I thought was neat is that all of these stocks are associated with, I guess, ephemeral ice cover. So they're not always covered by ice, but they have some ice at some point in the year. And he projects where and when different habitats are going to open up and when they will be ice-free over time, which was neat. But I think the really cool thing was learning that the Newfoundland stock and the Bering Sea stock are sisters. They kind of move in similar ways, and it seems to be associated with the Arctic oscillation and ice. But in that vein, I guess thinking about the northern Bering Sea and what would have to happen for it to be a potential fishing opportunity in the future is that we'd have to get the ice up. The crab would have to grow to larger sizes, and that would be related to temperature and likely the ephemeral nature of the ice up there eventually. But they'd also have to retain the larvae up there. And the currents really whip through that area. And I just wanted to mention some work that Buck Stockhausen has been doing too on individual based models and larval transport from area to area under different climate scenarios. This is a figure that I stole from it, but I'm not going to talk much about it, just to say that he's thinking about it, and the idea of larval retention is an important one for the potential for the Northern Bering Sea to be a future stronghold for snow crab. Okay, these I think are actually my last 3 slides where I'm supposed to wrap everything up and put a nice little bow on it. All right, so the collapse of snow crab, as far as I can tell, was related to the marine heat wave and the record number of crab in the area. The snow crab are not the first, they're not going to be the last. It's been interesting to see that there are some winners in the Bering Sea, like sablefish appears to be going through the roof. Some other, looks like pollock had a very good year class in the same year that snow crab crashed. It's been frustrating that I wasn't able to predict the collapse, but I think this is probably going to be an oft-told story as we move into the environmental space that we've not seen before. It's difficult to predict what's going to happen if you don't have something in the past to compare it to. But even if I could have predicted the collapse perfectly, I don't know what I would have done different. I think that some of the tricky things with the crab fisheries is that, and fisheries in general in the Bering Sea, is that the quota systems and the property rights kind of chain fishers to a given stock or set of stocks, and the rigidity of the system, which has been very useful and helpful in controlling fishing mortality and the race to fish, is going to be tricky to deal with as climate changes and stocks boom and stocks bust. And the best thing that I could really
provide from that if I was a fisherman would be to try to diversify as well as you could, but that's really hard to do in our current system. I'd also think that it would be really, like, fishers have a lot of political power, and I think it'd be really nice to see them all come together and try to have some common climate agenda, but it's been unfortunate. Like, there's been the trawlers versus the crabbers is already kind of a thing. They think that they're killing their crab and they don't. And some of that has to happen. There have to be crab that are bonked on the head and don't go on living by trawl gear. But based on the information that I have, I think that the changing climate is a bigger driver of changes in the crab stocks, or at least snow crab. I think modeling and management are going to get much harder in the near future. I think time variation in population processes that we didn't previously think varied over time are going to vary. This gets particularly hard when those processes are confounded and you don't have data to sort out what is what. I talked about MSY-based reference points and how they've been useful, but they get messy under climate change. I'm not going to talk about EBFM. I think that that's the direction that we probably have to go, but it gets so hard. Like, just the questions that we tried to talk about here barely scratch the surface of how messy and hard it's going to be to make decisions that don't have an underpinning of some very or relatively simple theory like maximum sustainable yield. All right, 2 minutes, I'm going to do it. So I think that it's been a really weird couple of years. it's been like, I feel sad for the crabbers. I feel worried for the Bering Sea ecosystem. It all kind of made me question what I thought I knew about management and assessment. I was grumpy that I wasn't able to predict the collapse. And that just kind of added up to some general frazzlement, but it's also been, will probably be one of the more memorable years of my career, I think. And I got to work with a lot of people, a lot of scientists that are really dedicated and interested in understanding what's going to happen to the Bering Sea. And I got to talk to a lot of stakeholders and sit and have beers with fishermen, which, if you guys don't do, you should go do as much as you possibly can, because you learn a lot. I don't know what's going to happen, but it's going to be a wild ride, and I'm happy that we got so many smart people thinking about it. Hope we get something sorted. And if you guys have thoughts on these that we didn't go through today, I would love to go on a walk or have an email conversation, have a beer or whatever. These are things this is basically what I think about these days. So if you have thoughts, I'm curious. Thank you for listening. If you want to, it's 3 o'clock. I don't care. If there's anybody online that wants to throw a tomato or give me a cookie, that's fine. You tell I'm hungry?
I'm thinking about it the entire time.
Uh-oh.
What did you tell the investment bankers when they called in 2018?
Yeah, I sent them waffles, meaning I didn't give them a very good answer. I said, the best information that we've got on the stock says that there's a whole bunch of crab coming into the system. It's corroborated by the survey. We see them in we're starting to see them in the fisheries as well. So it seems like they're out there. I don't know if they're going to stick around. They didn't stick around.
I have a couple. No tomato, that was great, Cody. Thanks for the presentation. From Jocelyn. Tobias says, great talk. very stimulating. Thank you.
Thank you.
Okay. Thank you for everyone coming online. We will be back in 2 weeks with Ian Taylor.
That's fun. What are you talking